In this video, we're learning about spatial accessibility. As a reminder, spatial accessibility refers to the relative ease with which the locations of activities can be reached from another given location. To measure accessibility, we're planning to use the two-step floating catchment area method. This method uses spatial data about the location of service providers and the supply of services at each location, along with the location of those demanding services to calculate a supply-to-demand ratio for each service location. Let's look at this equation we're going to use to calculate the two-step floating catchment area method and a hypothetical region to understand how this method works. First, let's imagine we're looking at a small town that is made up of 13 different neighborhoods. Each of these neighborhoods has a set of residents living within them that we can represent with a population-weighted centroid. Within this town, there are also 3 different healthcare facilities, represented by the 3 stars, A, B, and C. Finally, those facilities also have catchment areas around them that they service. The question we want to answer is, how accessible are the supply of healthcare from these facilities to each of these 13 neighborhoods? This is the kind of question the two-step floating catchment area method can help us answer. On the right-hand side of this figure is an equation that defines this method. It may look complicated, but let's break it down to understand how it measures accessibility. First off, we can see on the left-hand side we're trying to measure accessibility at a location I. On the right-hand side there are a number of terms, but the essential ones are that this equation considers both supply, the S, and demand, the D, at different locations. Second, what you can see here is that this is basically just a supply-to-demand ratio. But what counts in the ratio is restricted by distance, or in this case, travel time defined by the catchment areas around the different facilities. You may have noticed these 2 big summation signs. These are basically outlining the 2 different steps of the two-step method. Let's take a look at each of those. The first step is essentially saying, focusing on the supply location, how much demand is there around that location. The second step shifts back to focus on the demand at the neighborhoods and sums up those supply ratios for all the facilities that can be reached from the neighborhood. For each neighborhood then, this second operation tells us how much supply there is relative to demand, and if this value is greater than 1, there's enough supply to meet the demand. If all that is still a little unclear, don't worry. We'll work through an example to show you how each of these steps works. First, we'll need to know how much supply there is at each facility. We can imagine this is the number of doctors working at each facility. And in this case, Facility A has 12 doctors, Facility B has 3 doctors, and Facility C has 5 doctors. Second, we need to know what the demand is for each neighborhood. And in this case, to keep it simple, let's just say that each neighborhood has 1 person demanding healthcare. Now remember, the first step of the method focuses on the supply locations. And basically, for each facility, we want to know how much supply there is, how many doctors are working there, and also how much demand there is for those doctors from the catchment area that supply location services. Focusing on Facility A, we can see that the supply is 12 doctors. We can also see that the catchment area for this facility covers 7 of the demand centroids, and because each neighborhood has a demand of 1, there's 7 total demand for the services of this facility. So the supply to demand ratio here is 12/7. Repeating this step for Facility B, we can see that supply is 3 and demand is 4, giving us a 3/4 ratio. And then again, for Facility C, we can see that supply is 5 and demand is 5, giving us a ratio of 1. We just completed the first step of the two-step floating catchment area method. Now that we have those supply and demand ratios calculated for each facility, we can move on to the neighborhood perspective and perform the second step of the method. Basically, what we're going to do is look at how many facilities each neighborhood has access to, and then sum up those supply-demand ratios. For example, take a look at neighborhood 1. It's clear from the diagram that this neighborhood is only serviced by facility A, and the supply-demand ratio is 1.71, or 12/7 if you want to keep it that way. But look at neighborhood 2. Here we can see that neighborhood 2 is actually serviced by both facility A and facility B. In this case, our equation tells us to add up the two supply-demand ratios for those two different facilities. And so this neighborhood has an accessibility score of 2.46. If we repeat these steps for all the neighborhoods, we can calculate accessibility scores for each individual neighborhood. If we look at the pattern here, we can see that some neighborhoods have more access than others. And we have a measure of how accessibility varies across this particular town. In particular, we can see that some neighborhoods, like neighborhoods 2, 6, and 9, have particularly high access to healthcare, while other neighborhoods, like neighborhood 3 and neighborhood 10, have much less access. Neighborhood 10, in fact, has no access, and neighborhood 3 has less than one doctor available for potential patients, indicating a shortage of healthcare access or healthcare services in both locations. This should clarify the two-step floating catchment area method, one of the many different ways to measure accessibility. The question before us now is how do we use this method inside of a geographic information system to answer questions at a larger scale with real-world data.